In this video, we'll be going over example 2 from lab lesson 2A. So here's our multi-view drawing of this part that we want to model, and it looks like a shell and tube heat exchanger casing with the hot stream inlet and outlet on the sides, and the cool stream inlet and outlet on the top. From a quick glance, this part looks symmetric, and we can actually verify this by the center lines on the front view and the top view of our drawings. So this shows a plane of symmetry in these two views. In fact, all of the dimensions in the front view are actually dimensioned with the center line as the baseline, so we can definitely use this symmetry to our advantage when we're making the part. Breaking the part down into its features, we have a main rectangular prism that is lofted to a cylindrical feature, as the note indicates in the isometric pictorial. There are also holes on the top surface of the part, and we can see by the hidden lines in all of the views and the annotation in the top view that all of these features are hollowed out to a thickness of 3 millimeters. Lastly, we have these flanges on either end of this part with 2 counterbore holes on either side of the main opening, and the whole information is given on the side view as well. So to model this part, my strategy is going to be to start off by extruding a rectangle from the plane of symmetry, and then lofting that rectangle to a circle. We'll then extrude the circle out to make one main half of our part, and we'll also extrude the top cylinder on that half as well. We can then mirror all those features through a plane of symmetry, and then we can shell out those features to a wall thickness of 3 millimeters. Last, we'll have to model the flange, which will be an extrusion of the profile we see on the side view, and then we'll add in the holes, and we can mirror that as well. And then our final step will be to add one feature that I've yet to mention, and that is this chamfer on the top 2 holes. So we'll use the chamfer tool for that, and then our part will be complete. So let's get started. This part is dimensioned in millimeters according to the drawing, so I've opened up a standard millimeter part file in Inventor. And again, I'm going to start off by extruding out the rectangular prism for this part. So I'm going to start a 2D sketch. I'm going to start it on this plane here, which gives me my right profile, and I'm going to sketch out a rectangle. And I'm going to use the 2-point center rectangle that I used in the previous example. So here I can dimension the sides of my rectangle to be 40 millimeters in height and 50 millimeters in depth, according to our right view and according to the top view. And that gives us our rectangle. So we can finish this off. Our sketch is fully constrained. We'll finish the sketch. And then we can go ahead and extrude it the 50 millimeter distance indicated in the front view. So we'll extrude this out. Remember, we're just modeling half of the part from the plane of symmetry. The next step is to loft this rectangular face to a cylinder. So to do this, we have to create a new plane, and it's going to be offset from this face of our rectangle. Specifically, it's going to be offset a distance of 20 millimeters, which we can calculate from the dimensions we're given on the front views. And on this new sketching plane, I'm going to sketch out a circle. And the circle is going to have the same center point as the rectangle. So this is why I use the 2-point center rectangle for my sketch. So we can see in the top view that this circle has a diameter of 30 millimeters. And with that, our sketch is complete, so we can finish the sketch. And now I'm going to use the Loft tool to loft this face of our rectangle to our circle sketch. So we can click OK, and there is our loft. Now I want to extrude the circle out a distance of 10 millimeters according to the front view dimensions. So I'm actually going to go into my loft feature, and I'm going to make this sketch visible. We can then extrude this out a distance of 10 millimeters. And I'm going to make the work plane invisible so that we can only see this part of our sketch. And we can do the same with the sketch I just made visible. So there we have it. Again, I should be going and naming my features. So the first feature I can call rectangular prism. The loft, I'll just keep it as loft since that is what it is. The second extrusion I will call cylinder extrusion. And now what we want to do is we want to add in the top cylinder. So I'll start a 2D sketch on the top plane of my rectangular prism. We are going to sketch a circle. According to the top view, we can see that this circle has a diameter of 15 millimeters, and we of course have to dimension it. So it is located 30 millimeters from our plane of symmetry, and it is located 15 millimeters from the back edge of our part, which we can see in the side view. So now our sketch is fully constrained. We can finish this sketch, and we can extrude this cylinder up a distance of 15 millimeters according to the dimension in the right view. I'll name this feature top cylinder. And now we have essentially half of our part. So now we want to mirror this part across the plane of symmetry. So I'm going to select the mirror tool, and I have to first select all of my features that I want copied. So that will be this rectangular prism, the loft, the cylinder, and then our top cylinder. Next, I have to select the mirror plane, which is just going to be this back face of our part. And then I can just hit OK, and you'll see that our part has been mirrored. So now we want to shell out this part. So I'll be using the shell tool. And to use this shell tool, I just have to select the faces that I want to remove. So I'm going to remove both ends. I'm also going to remove the tops of these top cylinders. And lastly, I have to specify the thickness, which is going to be 3 millimeters. So I'll specify the thickness, and I'll click OK. And there we have it. Now our part is hollowed out. So our next step is to model the flange on one side of our part. Once we model that, we'll add the holes and mirror it to the other side. So I'm going to start a 2D sketch, and I'm going to start it on this surface of our part. And essentially, we want to have a flange that has the same diameter as the inner wall of this cylindrical feature. So that has a diameter of 24 millimeters. We can see this in the right side view of our part. And we see that our flange is created by a central circle with a diameter of 40 millimeters. We can see this where it says 2 times R20. So the two curves on the top and bottom of this main flange opening have a radius of 20 millimeters, meaning a diameter of 40 millimeters. And then on either end, we have two round features with radii of 7.5 millimeters, so that gives us a diameter of 15 millimeters. Now, since it's not explicitly stated otherwise, we can assume that these rounds are connected tangentially by lines. So I'm going to draw two lines connecting these two circles. And then I'm going to use the tangent tool to make sure that these lines are tangent to the circles where they intersect. So we'll do that. And that looks good. We still have 2 dimensions needed in this sketch, so that you'll see that I can drag this circle about. One of these dimensions is going to be making this center point of the outer circle 30 millimeters from the center point of the main central circle. And then we also want to make this outer circle aligned horizontally with the main inner circle, and that will fully constrain our sketch. We can tell that this is horizontally aligned because in the right profile view, we see that the center marks are all aligned and they have a dimension of 20 millimeters up from the base of our part, which is right in the middle height-wise of our part. So now I can copy these elements of my sketch onto the other side of the circle to complete our flange using the mirror tool in the sketch tab, which is similar to the mirror tool in the 3D model tab. In this case, I just need a mirror line rather than a mirror plane. So I'm going to go to the origin and I'm going to make the y-axis visible. And I'm actually going to project the y-axis geometry onto our sketching plane. So I can now use the mirror tool. I'm going to select these elements that I want mirrored about the y-axis, which is our mirror line. And now I can press apply, and it's all mirrored over, and our sketch is fully constrained. So that's handy. Now I can finish the sketch. And we want to extrude this outwards. So I'll have to select the profiles that I want to extrude. So we just have to make sure that we select everything here. And we can see in the sketch we want this extruded a distance of 7 millimeters. And there we go. Our next step is to add the holes to either side of this flange. So I'm going to use the hole tool for this. And in this case, I have these rounds and I can see that the holes are concentric with these round features because the center marks coincide with each other. So I can just click the surface of this flange and then select the edge of my round in order to place the hole concentric on this round. I'll do the same for the other side here. And although this one disappears, we can see that we have two selected, so we're making two holes. And looking at the dimension that we're given for these holes, we can see that these are two counterbore holes. So I'm going to select the counterbore option. They are threaded. They have an M8 thread. So this is an ANSI metric M profile, but the size is going to be size 8. And we want the designation to be 1.25 according to the sketch. Class 6H is good. We'll leave the direction. And we can see from the drawing that we want the threads to go the full depth. We can see this in the front and top profile views. And as far as behavior, we want the hole to go through all. The direction is fine. And we see that our counterbore has a diameter of 10 millimeters with a depth of 3 millimeters. So now we can click OK. We have our holes created. And our next step is to mirror all of these features of this flange to the other side of our part. So just like we did before, we are going to select our features that we want mirrored. So that's going to be this flange extrusion and our holes. And then we are going to select the mirror plane, which is in this case the YZ plane. And there we go, we have our flange mirrored to the other side. Our last step is to add the chamfer to the top cylinders. So with the chamfer tool, we just have to select the edges of these two cylinders. And we can see from the drawing that we want the chamfer to be a distance of 1.5 millimeters, and the angle is 45 degrees, which is the default. So we don't have to change anything here. We can click apply. And now our part is complete. I'll just go ahead and rename our flange extrusion to make sure everything's clear. And now we have our part, it's complete, so you can go ahead and try it out on your own.